mutually perpendicular, right? And we can define any vector in the form of I, J, and K. So it will have different components, right? So it will have X component, Y component, Z component. And then we can write the magnitude of this vector. So what is the magnitude of this vector?
Root of ax square plus ay square plus az square.
Good. This is the magnitude. And direction is A hat, which is vector divided by its magnitude. So these are the things that we have, right? And then we talked about, so the next thing that we talked about was the resultant of vectors. Right. So in the resultant of two vectors, you could be given three known quantities that would be magnitude of one vector, magnitude of another vector, angle between them. And then you have to find out the unknown quantity, which would be the magnitude of the resultant and the angle of the resultant, right? The direction of the resultant. This is direction. And what was the formula for that? So the resultant of two vectors using we can use the parallelogram's law or we can use the triangle. Both law we can use. And the magnitude that we found out was right. And what was the direction? Direction was simply this was so this was the result of two vectors, right? And then we studied the subtraction of two vectors. Right. So we studied that let's say we have a vector which is subtraction of two vectors, and this was what? So this was resultant, which was A plus B. Right. And then we find out R and this direction. So we have similarly we have this subtraction of two vectors, and the magnitude of this vector is and direction of this vector is how much? Yes, so these are the two things that we study in the subtraction of vectors. And after that, we talked about the multiplication of vectors. And there were two kinds of multiplication. One was dot product. The other one was cross product. Right, so this is A dot B. This is A cross B. So A dot B was how much? This was simply AB cos theta. And this was used to calculate the direction of or the angle between the two vectors. And then we had A cross B, which was AB sine theta and n. So this was because we are getting only a number, so this was called the scalar product. And this was a vector because we are getting another vector. So this was called the vector.
So is that n vector?
So this is n hat, right?
Okay, so yeah.
So n hat represents the direction of another vector. And what was the direction? How do we find this n hat? Yeah, do you remember how do we find this n hat?
We multiply it. So all the like what's the yeah. So if we have like vertical vector like a I mean 2i plus 5j plus 8k, and then another vector we multiply it, and then it's a long process, right?
Oh, so you are talking about the cyclic problem. We're talking about this kind of I, J, and K, and then cyclic. Right. So I cross J is K, cross I is J. And then I cross K is minus J, J cross I is minus. You're talking about this thing.
Yes, sir.
Okay, so, and we have a simple thing as well, right? So this is cyclic property. But to find out direction of A cross B, we use, right? So to calculate n hat, the direction. Yeah, because let's say if we don't know ijk, the vector is not given in the Cartesian, right? The vector is not given in the Cartesian form, then how do you find out this n hat? So we used Maxwell's right hand thumb, right? So how do we find out or how do we use this Maxwell's right hand thumb rule? So we place, let's say I want to find out, right? Let's say I have this A vector, I have this B vector, and I want to find out A, so I'm starting from A and then I'm going to B, A cross B, right? I'm trying to find out A cross B direction. So what I will do, right? Let me show you these kind of example we have discussed, right? When you were in your 11th standard, right? So let's say these were oh, uh, so these right? So these are vectors, right? This is A, this is B, and
Yes.
what was the right hand thumb rule? So we place our fingertips in the direction of A vector, right? So these are the fingertips, and these are in the direction of A vector, and then we cross our these four fingers, right, in the direction of B. So whatever the direction our thumb is pointing, that would be A cross B direction, right? So let's say
Yes.
this is a sheet of paper. In the sheet of paper, you have vectors. So these vectors are in a plane, right? In a sheet, in a board. And then the third vector, which is perpendicular to these two vectors, that would be the cross product direction, right? So the cross product direction would be coming out of this sheet or out of this board or out of this plane. So what would be the direction of A cross?
K cap.
K cap, absolutely correct. K cap, or we can say outwards, because we don't know what is K cap, so we can say outwards, right? If these are
Yes.
perpendicular, right, then we can say that that would be K. So then we can say that this is I, this is J, and then that is. But if we don't know that that is I, that is J, because that is not J, Right. This one we can say that this is I. This is not J. So I cross K would be I cross K, J would be K. That means if this is the case, this is I, this is J. So then I cross J is K. But let's say we have these two lines. This is not I hat, right? This is not J hat. But we know that that would be perpendicular. That would be outwards. Is it clear?
Yes, sir.
Yeah. So you are absolutely correct that I cross. You are absolutely correct that I cross J would be K. This is absolutely correct. But let's say we don't have I, J, K direction, right? Then what would be A cross B? So that would be outwards, right? Is it clear? So how do we represent the outward direction? So if you look at an arrow, right? This is the arrow, this is the tail. So this is the head and this is the tail. So if the arrow is coming at you, so you will see the pointed thing, right? You will see the arrow as a pointed object. But let's say the arrow is going away from you. So let's say you are finding out what is B cross A, right? B cross A direction. What would be that? Just use the idea of that Maxwell's right hand thumb and just
Inwards.
in, right? Absolutely correct. So this would be inwards. And if you look at the arrow which is going away from you, so you will see the tail. So you will see this kind of structure, right? This is the tail of the arrow that you will see, right? So this direction, so this is a new kind of direction. This is showing outwards. This is showing in. So you'll see in some chapters that the direction is represented by this thing or this thing. So this is outwards and this is inwards. Right. In IJK formalism, outwards, as you have said, that would be K hat. Inward, that would be minus K. Right. So this is
Sir, if it goes outwards, won't the won't the back be facing us? And if it goes inwards, then the point pin will be facing us.
so the arrow is coming at you, right? So let me just show you this. This is let's say this is the arrow, right?
Yes, sir.
So this is the point. If it is coming at you, right? So let's say that it is coming at you. So I will see this pointed object, right? I will see this
Yeah,
point.
but you told outwards, right? So
Yeah. So
outwards meaning opposite your direction, right?
outward meaning coming at me. Outwards.
Ah, okay.
Outwards. Coming at me. Outwards meaning coming at me. Inwards meaning it is going away from. So for you it is coming towards you because my inwards is your outwards, right?
Yes, sir.
So if it is going away from, so this is going away from, right? Then I will see this
Yeah.
backside. Backside
Okay.
is cross. Front
Okay,
side
sir.
is dot.
Yes, sir.
Yeah, you can see your pen, right? If you put your pen towards you, then what you will see? If you put your pen towards you,
The
what you will
point.
see? Point. So yes, that is outwards, right? And yeah, if it is going inwards, so then you will see cross.
Okay, sir.
Okay, so these are the things that we have learned in vector portion. And there was this thing also which uses the idea of dot product, right? So where do we use this dot product? Of dot product, and this is very important. The use of dot product is one is find out angle between vectors. Second point is we use this to find out the projection of vectors. right? And yeah, I missed one thing, one more important thing, and which was the resolution of vectors, right? So we have also talked about the resolution of vectors. And what was the resolution of vectors? So if we have this vector, right, this is the x-axis, this is the y-axis. If it is making theta angle, and this is vector A, so this component was, this was the, what was this component? This was the x component, right? Horizontal component.
Yes, sir.
And then we had this part. This part was AY, which was vertical component. And do we remember what was this component? Just
A
give me
cos theta,
good,
AX
uh,
cos theta.
good, good. So no, that is A cos theta, right? AX, the X component is A cos theta. Yes, absolutely correct. So you remember all these things. Good, that is. And AY. What was that?
A sin theta.
A sin theta. Good. So these are the crucial things that we have. So this part was A sin theta. Right? We have to always remember what is whatever the component which is making the angle theta. So that would be cos component. Whatever is the perpendicular part, that would be. So this is resolution of vectors, subtraction, multiplication, and then the use of dot product, that was to find out the angle between the vector, projection of the vectors, right? So yeah, let me just complete these things, and then we'll do some questions, right? So this part we'll understand this part by doing some questions. Let us understand this part, projection of vectors. Let's say let's say we have vectors. So let's say we have two vectors. This is A, this is B. So I want to find out projection of B, right? Projection of B on A. So what I will do, if I want to find out, so these are two vectors, right? This is A, this is B, and I want to find out projection of this onto this. So I will have to drop this vector in this. Right? So this is the projection of B along A, right?
Yes, sir.
And can you tell me what would be the direction of this projection? What would be the direction of this projection?
Along A only?
Along A. So that would be A hat, right?
Yes, sir.
Good. Okay. So remember all those things. Good. So that would be, so if I write part A is projection of B along A. So that would be A dot B. And I'm taking projection of B along A. So I'll have to divide with A magnitude, and direction would be A, right? Is it clear?
Yes, sir.
And then second part is projection of A along B. So that would be A dot B divided by B. And then this is B, right? So this would be the projection of, and remember, these are projection vectors, right? If I'm only talking about projection only, so I'll have to just write these things. But if I'm talking about projection vector, then I'll have to write these terms. These are the crucial things that, right? And then how do we, what is the use of this cross product? right? So use of this. So let's say I have this A and I have this B vector and I have this parallelogram. This is A, this is B, this is B, this is theta. So the area of parallelogram, this would be A cross B. Okay. So is it clear? Yeah, is it clear?
Yes, sir. It's clear.
And then, yeah, so then this is the last part that is how do we calculate cross product using the idea of matrices and determinants, right? Matrix and determinants. How do we use these two ideas to calculate the cross product? So I guess this thing I have not done, right? So let's say I have this A vector, which will have three components, and then B vector, which will have three components. And I want to find out, so to have that long process, IJK cyclic property. You can either use,
Yes, sir.
yeah, so you have these long processes. You can use these property to calculate the gross product, or you can use the idea of determinant, right? So what is that? So in determinant form, A cross B would be determinant of this matrix. What is that? This is I, J, and K. And then you have this AX, AY, AZ, and then you have this BX, Y. So you take the determinant of this matrix, right? How do you calculate the determinant? So firstly, you take I hat, right? And then you cover or then you discard the corresponding rows. This is the corresponding row and this is the corresponding column, right? You discard these two things. Let me do the different way. Discard these two things and then you take this product and then you take this product. So what?
Yes.
Yeah. So what I'm getting?
AYBZ plus AZBY.
You have to do subtract. You have to take this.
Oh, minus AZBY.
So this part is it. Now, what you do is that you cover. Now you have to take this jth column. So then you will apply the
Yeah.
same thing, right? You will apply the
Yes,
same
sir.
thing,
AX
but for consistency, you have to take this as minus.
minus. Yeah.
Yeah, so this part,
So
and
it
then
will be AXBZ minus AZBX.
yeah, so this would be ax bz and minus az, and then the remaining parts. What is the remaining part? That is k hat, and then again you discard the corresponding rows and columns. Discard this one, discard this one, so you have this one, right? So this would be how much? This would be ax by and then ay. So you don't have to remember this form. You just make this matrix, discard all these things, and you apply it, right? So that is the last topic, which is the dot product that you have learned in cross product that you have learned here. 11th standard. So these are needed, and we'll do some questions using these ideas, and then I will jump to the electric charge methods, right? So first we will just recap all these things.
So for the J component, it will be AZBX, right?
Yeah, so for the yes, for J component,
The AZBX would be first, and then it will be minus AXBZ, right?
yeah. So if you are taking right, if you are taking here positive sign, then that would be AZBX minus AX, right? But I have taken this minus sign in here.
Okay, so
So then you have to, because
yeah.
I want to, right? So how, what is the consistency? How am I taking the product? I'm taking from left to right, right? My arrow is going like this, right? My arrow is going in every situation. My arrow is going like this. But if you take, right? If you take the J part, so your arrow will go like what? From here, your arrow will, right? So it will go from left to right or right to left. But this is how we calculate the multiplication, right? So to make it consistent, we take this negative sign in here and then we multiply this. Is it clear? Because if we were taking this thing, right? If we were taking I part, so we multiplied this first and then this first, right? We moved ahead for this. But for the J part, if we multiply this one, so then we will have to take the next. That is clear. Okay, is it clear?
Okay.
Okay, so there is this two minor and all those things in matrix multiplication that we have to take care of. So that is why this negative sign comes. That is another aspect that. So these are the things that we have to keep in our mind, right? And yeah, as I was discussing this with Rishita, that we have discussed these portions in your 11th standard. And when you were doing this superposition principle of electrostatic forces, right? Then you also they recapped these things, right? Amna ma'am has recapped these things, right? Right, guys?
Yes.
Yeah. So then you guys do need to put it down. So now we will do some questions, and then these would become clear, right? So let us do certain questions, and then we'll talk about. Then we'll go to the next chapter, which is electric charges and fields. So as I was discussing that there would be some new topics which are not there in the CBSE portion. So those parts so I will talk about in detail, and then in the rest of the parts I will just do the questions, right? So we'll only discuss the questions, but we'll not discuss the conceptual part because those parts, those portions you have already discussed in the CBSE. So we'll only do the questions, and whatever part which is not in the syllabus or the CBSE syllabus and which is there in the JEE syllabus, those portions we'll talk in detail, those conceptual portions. So for example, you have those potentiometer and that meter bridge. So that part is not in the CBSE, but you have that in your JEE syllabus. Similarly, you have the Gauss law of sphere, right? And hollow sphere and that solid sphere. So those parts are not in the CBSE portion, but we have that in your GX. So those things we'll talk about, right, in detail. But we'll only do some questions. So in the next class, what I will do is that I will talk about, because you guys have already understood or you guys have already learned about Coulomb's law, and then you have already talked about, you have already learned about this equilibrium, right? So if I can ask you that, how many kinds of equilibrium you guys have done? Electric charges and fields. How many kinds
Sir,
guys?
can you repeat?
So I'm asking that how many kinds of equilibrium you guys have learned in your basic question. That has been done, right? Yeah. So after Coulomb force, you have equilibrium topic, and in that equilibrium, you came across two kinds of equilibrium. Can you guys tell me about that? What were those equilibrium? Guys, remember that one was that only equilibrium was that only one point was at equilibrium, right? And the second equilibrium was that system was at equilibrium, right? So you would have understood two kinds of equilibrium, right? Is it clear? Did you guys? So did you guys study?
Yes.
Yeah. From this point, you calculated that what is the distance that we have to put the virtue, and from this analogy, calculated that what would be the nature, what would be the distance, position, and what would be the magnitude of the third charge, right?
Sir, your voice isn't really clear.
Oh, so this is happening for you as well. So which means that my internet is not working. Is it faint or is it not? Is it breaking or not? What is happening?
So it's faint.
It's faint. Oh, okay. So it's faint, meaning that I have to increase my voice now, right? So let me do that. So let me change this. Okay, how is my voice now? How is it now?
Yes, it's better.
It's better now.
Yes.
Okay, so okay, so yeah, I will talk about these scenarios in the electric charge. But firstly, we have to solve these questions. So we have to recap the vector function, and this would be very crucial because electrostatic force, that is a vector quantity, electric field, that is a vector quantity, right? We have also okay, torque we have not done. So you will come across this torque, which would be a vector quantity, and then dipole moment you are doing currently, right? So dipole moment is also a vector quantity. What is the direction of the dipole moment? Yes,
Negative to positive.
yes, absolutely correct. So from the negative charge to the positive charge. So that is the direction. Good. So we'll talk about those questions, right? But firstly, we have to recap this vector because
Sir, will we also be covering 11 topics or will we only start?
yeah, we will have some newer topics. Is what did you say?
So, like, will we also be covering 11 topics?
No, no, no,
Topics in
no,
class 11?
not 11th portion, right? Because it will take ages to cover those 11th portion. So whenever this 12th portion is completed, so this would be the scenario that Amna ma'am will do the CBSE portion, whatever she is doing currently. So those portions or the JEE syllabus of those portion I will, right? That is how we will proceed, right? So we will
Okay, sir.
cover only those portions. So whenever Amna ma'am is completing the first chapter, so then after that, whenever it is completed, then I will try to complete this first chapter for the JEE portion. And then she will start the second chapter. Then whenever it is completed, so then I will start the second chapter. So that is the scenario, right? So we will parallelly talk about this JEE syllabus. And yeah, if all those syllabus are completed, then we will recap those 11th questions. But as of now, we'll only focus on this 12th question. Okay, so let's start with this first question, right? So we have all these questions. We have already learned about all these things. So we'll do all these questions. Okay, so let's do this question. So this is based on, okay, let me take this question. It's- Okay, let's do this. So we have this vector, right? P plus Q is the resultant. P minus Q is the subtraction. Where P is perpendicular to Q, when at an angle theta 1 to each other, the magnitude of the resultant is this. When they act at an angle theta, the magnitude of their resultant becomes this. This is possible only when theta is less than theta 2, right? And then in the situation given, theta 1 is 60 degree and theta 2 is 90 degree. So we have to find out all these things. So two forces P plus Q and P minus Q. And we know that P and Q are perpendicular to each other. So we have to find out the resultant of P plus Q and P minus Q when their angle is theta 1. And then we have to find out the magnitude of the resultant when the angle is theta. So these are the two scenarios, right? So we have P plus Q vector. So P plus Q vector, right? And then we have P minus Q vector. So let's name it S. And yeah, so let's name it, this is R. And this is S, right? So now we have to find out what is, right? So now we have to find out what is R magnitude, and this would be how much? What would be this magnitude? Yes, what would be this magnitude? Yes, uh, what would be this magnitude? This would be simply P square plus Q square, and the angle between P and Q is how much? That is 90 degrees. So this would be simply P square plus Q square, right? What would be the magnitude of S? That would be also P square plus Q square. Right, guys?
Yes.
Now, the second part is that we have to find out the magnitude of resultant of R and S, right? So this magnitude we have to find out, and we have to also, so this is the case first. And the angle between the vector is what? The angle is theta 1. So what would be the resultant? Let's say, let's name it as whatever. So let's name it as RS. This would be R square plus S square plus 2RS.
So I
And
have math class after this. No, no.
after 5 minutes, right? After 5 minutes, you have math class, right?
Yeah.
So yeah, let's do this question for 5 minutes, and if it is completed, then it's okay. But yeah, then there are so many questions which are left, right? So we have all these questions. Yeah, we'll see that if we are able to complete. So in the next class, we'll do this. But at least let's do one question. This would be cos theta 1, right? And we know that how much is this magnitude. So they have said that the magnitude of their resultant. The magnitude of their resultant is root of 3p square plus q square. This is the magnitude. And this is r square plus s square plus 2r into s. Right, I should name it as, let me name it as, what should I name it? Let's name it as t. Right. And then if we square these things, so if we square these things, so what we'll get? We'll get 3p square plus 3q square. And r square is how much? That is p square plus q square. S square is again p square plus q
So
square.
how did I get under root 3 p square plus q square?
Yeah, how did I get under root 3 p square plus q square?
This.
Good. So in the question, yes, whenever you guys have any doubt, please don't hesitate to ask, right? You have this thing, and if you see that the magnitude of their resultant. So we have one vector, right? We have one vector which is p plus q, and one vector which is p minus q. And then we are taking the resultant of, let's say this is a vector and this is b vector. So the resultant of E and B we are taking, and their magnitude is this. So this was given, right? You have
Yes.
A vector, you have B vector, and the resultant would be what? That would be A plus B. And let's name it as some T vector. So magnitude of the resultant would be A square plus B square plus 2AB cos theta. Right? This is the magnitude of the resultant. And in the question, they have said that this is root of 3p square plus q square, and they have said that the angle between these a and b vector, that is theta 1. So that is what we have applied, right? So we have first found the magnitude of the a vector, which is this one. We have found out the magnitude of this b vector, which is this one. And then we are finding the magnitude of resultant of r and whatever this another vector is, right? So whatever this another vector is, right? Okay, I guess the time is up, right? So you guys have other classes. So what I will do is that I will stop, and yeah, we can discuss this question in the next class. So this is the first case. We solve this thing, right? We solve this thing, and again we use this idea. So the angle is changed, right? Angle is changed and the magnitude has changed. So then the case second is the angle is theta 1 and magnitude is root of 2p square plus q square. So this is the idea that we have to apply. We have to solve these two scenarios, and then we can get the theta 1 and theta 2 values. That is the idea of this question. We'll stop in here, and then we will discuss this question later. Right. Okay, so yes, bye guys, and yeah, I will talk about this question in the next. Okay, so Har Sri Harsha, how should I pronounce your name, right?
So you can call me Harsha.
Harsha,
Yes.
good. So, yeah, so, yeah. So Harsha, you joined late, right? You joined half an hour late. So please,
Yes, sir. I had a
because
chemistry class.
oh, you had this chemistry class. So then I will